This video is a strategic policy brief on India's 2026 semiconductor mandate, addressing the collapse of global supply chains and the multi-layered ecosystem needed to replace 5 crore daily chip imports. The 2026 global semiconductor shortage is a definitive stress test for national survival. India's current vulnerability is high, importing 5 crore chips daily. Controlling logic gates is now the equivalent of securing physical borders. Without domestic silicon, India's digital infrastructure is vulnerable to global export restrictions. High-end fabrication is an existential requirement. The 91,000 crore rupees Dholera plant is more than just a chip production facility. It is a training ground for generational sovereignty, anchoring intellectual property, and establishing a new domestic supply chain, encompassing workforce and high-purity chemical supply. Subsidies alone cannot bridge the gap between logical design and physical execution. While India has a strong design workforce, there is a complete absence of a commercial-scale physical manufacturing culture requiring tacit cleanroom knowledge. Policy interventions are artificially steepening the manufacturing learning curve. Measures like curriculum overhauls, EDA democratization, and virtual cleanrooms are preparing 65,000 professionals, reducing required cleanroom training by 40%. India is architecting an insulated multi-layered industrial ecosystem. This stack includes the physical fab, a chemical foundation with dedicated domestic plants, and a mentorship and capital ecosystem, bridging global and domestic heavyweights. India is replicating the East Asian blueprint of industrial compounding. Like Taiwan's trajectory, securing mega investments from global equipment manufacturers establishes R&D hubs, initiating the transfer of undocumented, tacit knowledge critical for yield optimization. ISM 2.0 catalyzes the transition to sovereign IP creators through capital injection and domestic ecosystem activation. This includes a shift to open-source RISC-V architecture and the approval of 24 domestic design projects, with real-world integration underway. Strategic patience is key, requiring a legacy baseline before advanced nodes. Phase 1 focuses on stabilization, with legacy baselines, a disciplined workforce, and chemical supply. Phase 2 targets specific verticals like silicon carbide. Phase 3 aims for ultimate sovereignty. Fusing components for the silicon shield involves 3 pillars: human capital, an insulated supply chain, and a geopolitical alternative. This structural fusion protects India's digital public infrastructure and elevates its global bargaining power. The 2026 semiconductor crisis is driving India from 5 crore daily imports to a $1 trillion sovereign hardware economy. India is architecting a self-reliant technological era where economic destiny and national security are fabricated on sovereign soil.